Okay, so continuing to move forward through introducing this chapter, we're going to try to get a sense of the overview, the strategy of how we're getting this job done. So again, analysis of variance. We're going to calculate variance and then analyze it, break it into pieces. And we're going to need the information for a little bit on page 335, table 12.1. So pause the video for a second, go to page 335, table 12.1. Okay, so what we see there is 3 different treatment conditions represented on here. Again, look at it in your own book, of course. I know you can't see it here. Treatment 1, also labeled conveniently as sample 1. And we can see there's 5 scores there. So there were 5 people in that sample scoring 4, 3, 6, 3, and 4. Treatment condition 2, the second sample, scored 0, 1, 3, 1, and 0. And treatment condition 3, the third sample, scored 1, 2, 2, 0, and 0. 3 different samples, 3 different treatment conditions. Let's continue using the example of medication that I started earlier. So condition 1 is the control group, 0 milligrams of the medication, whatever it is. Treatment condition 2 is 10 milligram dose. Treatment condition 3 is a 20 milligram dose. And we want to know, is there any difference between these groups? Is the 0 different than the 10? Is the 0 different than the 20? Is the 10 different than the 20? We're going to do all that in one big calculation. So the first thing we're going to do is get a sense of the total variability for the entire study, our total variance. So put all of those 5, 10, 15 scores together, the entire study, the entire experiment all at once, how much variability, how much variance is there? So we're going to make a calculation of variance for all 15 of those scores for the entire experiment, the total variance. And then we're going to analyze that variance. Again, we're going to break it into pieces. And there are 2 pieces that we are going to break this into. So let's go back to the table here. And let's take a look. Let's just look at the first 2 groups for a second. It applies to all of them, but let's just concentrate on the first 2. So the first group, again, 4, 3, 6, 3, 4 with a mean of 4 points. Second group, 0, 1, 3, 1, 0, mean of 1 point. And the third group, even, we could look, of course, different numbers again, 1, 2, 2, 0, 0. Every group scored differently than the others. There is variance between, there are differences between these 3 groups. Group 1 is different than group 2. So the next thing we need to calculate is what is the variance between the groups. So this would be called between treatments variance. So what are the differences between the treatment groups? Differences between groups 1, 2, and 3. Now, if we look at that, again, just kind of concentrate on group 1 and 2 for a second. Why would they score differently from each other? Why would their performance, why would their measurements be different? Why would group 1 score differently than group 2? Well, group 1 is taking 0 medication, and group 2 is taking 10 milligrams of that medication. So we are hoping as researchers that at least in part, the differences between the treatment groups is due to the treatments. The treatment effect is what we are absolutely hoping is what's causing these differences between the treatment groups. But that's not the only way to explain why group 1 scored differently than group 2. Remember when we talked about independent measures t-tests, we talked about something called individual differences. Maybe group 1 scored differently than group 2, not because of the treatment, but because they're literally different people. We're comparing strangers to strangers, might be apples to oranges, individual differences, sampling error, some kind of measurement error. Again, if there are differences in scores that are not because of the treatment, it's all just called error. So there's 2 ways to explain why there are differences between the 3 groups. Some of those differences are going to be due to the treatment effect, And some of those differences are just straight up error. Again, sampling error or individual difference error or what have you. Now, let's go back to the same table. Here again on page 335. Now let's just look at group 1 for a second, but it applies to all 3 of them, but look at group 1. Our scores are 4, 3, 6, 3, and 4. Well, those 5 people are all in the same treatment condition. Those 5 people are all in the no medication group, but they still score differently from each other. Why would that be? We jump over to sample number 2, scores 0, 1, 3, 1, and 0. Those people are all getting the same medication at the same dosage. They're all receiving 10 milligrams of the exact same medication. If they're all getting the same treatment, why are they scoring differently from each other? And the same thing, of course, for column 3. They're all getting 20 milligrams. If they're all getting the same treatment at the same dosage, why are they performing differently? So what we're looking at now are the differences within the treatment groups. So we call this within treatments variance. So again, between treatments variance is looking at the differences from one group to another group. And the within is looking at the differences of the scores within a group. Well, what caused all those people to score differently from each other in the same treatment condition? Well, obviously not the treatment, right? If everyone's taking the same pill at the same dose, it's not the pill that's making them score differently. It's individual differences or sampling error or. So it's all about error on this side. So different forms of error, but it all comes down to error. So this is our analysis. We're going to take the total variance, look at the amount of differences we see that's due to both treatment and error, and compare that to the differences we see that's just due to error. Remember, I've said to you now many times that every statistic formula is built the same way. It's always a fraction, it's always a ratio, with some value on the top and some value on the bottom. And what does the top always measure? How many differences do I see? What are the differences I measured? That's your between treatment variance. And the denominator, we said, is always just straight up error. We've been calling it estimated standard error, or started with standard error. Well, guess what? This is our measurement of just straight up error now. So this is going to end up as our numerator, and this is going to end up as our denominator for our final calculation. So once we know this is our measurement of the treatment effect with some error, and we're going to divide by that, just error. How many differences do I see between the groups? Yeah, but how much of that difference is due to just random circumstance, random chaos? That has a couple of extra implications for us as well that we'll get into in the next video clip from here.